Hi, in this video we will show how did we program a pack using Studio 5000 connected with the digital twinning factory Ealo and with pneumatic actuators.
We are going to divide this video into who we are, explain the communication architecture, the programs we use, our routine, and show its virtual and physical implementation. Finally, we will talk about some conclusions.
This project, one of many from the classes SCADA and industrial controllers, was developed by Felipe Medina Ealo and Felipe Medina, both being students of Mechatronics engineering from the National University of Colombia, Bogotá. First, it is important to explain the Optimization Lab internal network. All the packs are connected to the network using specific IP addresses. There are two ways in which we can enter the network. The first one is physical, by Ethernet cable, and the second one is by VPN or Wi-Fi. Then, we use the communication driver RS-Links to scan and create the network of packs in the computer. By doing this, we then were able to download the program from Studio 5000 to the pack's CPU directly. The connection between Studio 5000 and Factory I/O was made by selecting the pack's manufacturer and IP address and using the same variable names in both programs.
The project takes place in a warehouse, in which boxes are being transported from one point to another one by using two conveyor belts. The second conveyor belt only moves one box at a time, so when one box is on it, the first conveyor belt is stopped. As soon as the box has arrived at destination, the first conveyor belts move again and the process starts over. To prevent two boxes at the same time on the second conveyor belt, there is a divider in the middle that activates when the box enters to the second conveyor belt and deactivates when it leaves. Two sensors are used, one at the end of the first conveyor belt before the divider and the second sensor at the end of the second conveyor belt. There are three buttons. The stop button pauses the two conveyor belts and leaves the divider in its current state. The start button starts but also resumes the process after being stopped at any moment. The emergency stop will be explained later on.
One concept important to understand before we move forward is emergency stop. What makes this button different is that it isn't a push button but a self-latching one. This means that after an emergency stop button is depressed and the contacts open, the emergency stop button must remain in the activated position until deliberate reset. The start button will not put the system into work unless the emergency stop button is resetted. During this period of time, the two bent conveyor belts will be stopped and the divider will remain in the position it was before. Once the emergency button is resetted, the start button needs to be pushed in order to start again the process. This video shows how the program works in the digital twin. We can also put the two programs side by side, so it is possible to see how the different stages from the program correlate to the digital twin movement. This stage was set in the automatization laboratory. It includes two pneumatic actuators controlled by two electric valves and one monophase motor with its own protection and contactor. The motor is related to the movement of the first conveyor belt, the simple piston to the second conveyor belt, and the double effect piston to the divider. So when the digital twin version is on, the real version will be on as well. Two push buttons are also used, as the start and stop button.
Pero sí, yo estoy escuchando de ¿cómo?
Aquí las temporadas de Medina, bueno, mientras grabamos todo y está viéndose el OBS, o sea, el factoría ahí está viendo el OBS.
The main conclusion of this project is that the use of a digital twin means cost and time savings, as it speeds up the programming of the PLC and helps to identify errors and fix them. Therefore, we are also protecting our physical components and workers. It is also recommended to gradually connect each one of our devices after the digital twin is perfectly working. We also learned the importance of using the amazing flexibility of the software to achieve objectives with a given hardware. Since hardware changes are often expensive and troubling, changing the program is a lot more easy and probably enough. We hope you enjoyed the video and thanks for watching.